there's international agreement that even if we did our darndest to decarbonize, to stop using fossil energy as much as we can, we're just not going fast enough. And we probably even can't get all the way to zero because there's just too many industries. Farming is one of them where we produce greenhouse gases that we don't have a way to avoid.
Yeah.
So we got to actually figure out how to suck, vacuum some of that extra greenhouse gas or CO2 out of the atmosphere. And I just see that as such a big win for agriculture because that we know that that carbon is actually organic matter. Organic matter is half carbon, and so there's nitrogen, phosphorus, and water holding capacity, and diverse microorganisms, and all these other what we call co-benefits that come along with that carbon. And so all across the world, nations have agreed that yes, we need to focus on this, that agriculture is a big place to focus. The carbon that we put back in our soils gives us so much benefit locally, even if the climate benefit is very diffuse and very hard to kind of even wrap your head around. It has these immediate benefits in terms of our soil health.
Welcome to the Real Organic Podcast. I'm Linley Dixon, co-director of the Real Organic Project. We're a grassroots, farmer-led movement with an add-on organic food label to distinguish organic crops grown in healthy soils and organic livestock raised on well-managed pasture, all without synthetic fertilizers and toxic chemicals. You just heard from Jennifer Pett-Ridge, a senior staff scientist at the Lawrence Livermore National Laboratory. Jennifer's work as a soil microbiologist specializes in carbon sequestration and understanding how soil microbial communities are affected by different management practices. I had the pleasure of putting on a soil workshop at EcoFarm with Jennifer about a month ago at the EcoFarm conference in California, and this is one of the conversations that followed. Hope you enjoy it. Okay, so thank you so much, JP, for joining us. We had an amazing workshop at EcoFarm, and I thought it would be really fun to take the time now to kind of dive into the things we didn't get to, or maybe just kind of expand on some of the stuff that was covered. And the goal was to really talk about annual crop production. We know that there's so much more potential in perennial crop production for
Yeah.
sequestering carbon. And so much of your work is looking at how to store carbon in soils. But as annual crop producers, we just have a harder time doing that. So I was wondering if you could just kind of start with that overarching theme of, in your experience, is there potential for annual crop farmers to sequester carbon, or are we more just thinking of how to keep carbon cycling on our farm, and that might be the best we can do?
Yeah, that's a great question, Lindley. Thanks for having me here to talk about it. Um, uh, I think that those two things that you just brought up, you want both to occur. It's kind of funny that maybe in the last 10, 15 years, our thoughts about soil carbon and how it comes to reside in the soil and persist for longer periods of time and maybe even accumulate have really changed. There was a kind of seminal paper published in about 2011, and we went from really thinking about soil carbon as something that is, we use the word recalcitrant, meaning that it's, kind of nasty and just hard for microbes to eat.
Stable.
Stable, yeah, yeah. Or sequestered. There are a lot of words that we kind of try to avoid now because we found that the carbon that's really old, that's lasted for thousands of years in soil, and we use 14C dating to tell us that that carbon is actually made of sugars and amino acids and really yummy stuff that microorganisms should love to eat. So that's why I'm, long story short, saying it's important to keep carbon cycling and turning over, and that flywheel is actually part of growing the stock of carbon in soil. And so those things are not mutually exclusive, is one thing. You brought up, can we increase soil carbon in our annual croplands? And I want to absolutely just clearly say yes. There is really good evidence that we can do that. And it does take careful management because the standard across the US, and I know we're here in California and you're Sorry, you're down in Arizona, is that right?
Southwest Colorado.
Southwest Colorado, forgive me. Um, in a lot of the U.S. and sort of the Corn Belt, the the standard is actually that we're losing carbon. We're not even at a baseline, a flat baseline. But that can be stopped a couple of ways. And I think the first one that a lot of folks think about is no-till. And when we looked at the literature really carefully on no-till, that there's so much variability from site to site that it doesn't reliably cause soil carbon to increase. What I guess it does is kind of holds the line. It prevents a lot of loss and certainly erosion loss. But what we saw is really consistently having a benefit is cover cropping. And so putting a crop in and having in the wintertime and having photosynthesis happening all year long is just causing that flywheel to spin more of the time. And there's other techniques too that we can get into, but I should probably stop there and let you have a little chance to talk, to say something more.
Yeah, no, I'd love to dive into that no-till thing because it was really traumatic as an organic farmer to go to DC last year. We were lobbying for organic practices in the Farm Bill, and it was kind of like this overarching statement that all of the every representative we met with, because it was a bunch of organic farmers and we divided and conquered, we all came back together and said, everybody's saying organic cannot be climate smart because we use tillage. And so no-till was like what was working, this concept of no-till in Washington. And I took some time to look at some of the research too, and I don't know if you agree with what I found, but they were showing like higher carbon sequestration maybe in the top layers and not so much in lower layers. We're not looking at, in my opinion, like full cost accounting, right? Cradle to grave of these farming practices, applying synthetic fertilizers on the surface, not really incorporating them, made it so that they were, the soils had greater cracks in them and the fertilizers were going down to the drainage tiles more readily. So you were having algal blooms. And I was just like, we need to take a deeper look at these systems. And some of the concerns I always have are like these point measurements as opposed to full cost accounting. And I'm just wondering if things like that come up in your research, but also, are any carbon markets working to kind of like, I
Oh
worry
my.
that they just take these point measurements, like, well, how deep are you measuring, over time
Yeah.
and all these
Yeah.
things. So just kind of throwing a big bag of worms at you and
Oh, well, I resonate with so many of those comments. I think that I love that no-till has been embraced by very conventional farmers and all the organic farmers I talk to as well aspire to be able to do maybe not no-till, but at least less tillage. That nobody wants erosion. Nobody wants to disrupt those wonderful mycorrhizae and the things that happen, the aggregates that form when we don't till. But I hear you. Organic farming, it's really hard. You got to get rid of the weeds. And if you're not going to put on some sort of chemical to do that, tillage has a place. But I've also learned it's not black and white. It's there's really wonderful farm tillage that happens that's, kind of one turn or uses modified plows that are much less destructive and don't just pulverize all of the aggregate structure. So that's my comment on no-till. Um, uh, you talked about a couple of other things. You talked about carbon markets and accounting, and um, absolutely, I'm with you that we can't just take point measurements. We can't take just measurements at the surface and really understand the entire system. And no, there is not a carbon market right now that I think is really doing a good enough job, though of course, you could collaborate with Indigo or Nori or Vera, these sort of voluntary marketplaces, and probably get paid for particular practices right now. I think that in another 5 years, we're going to have a much more reliable marketplace with what they call measurement reporting verification standards that are more well agreed upon. But the sticky thing right now is the measurement. And those point measurements, just like you said, they're hard to do at anything below maybe 20 centimeters. Um, they are hard to do often enough. You know, a single field, you might need 15 measurements in a hectare. That's that's cost prohibitive for most growers. For an academic or a researcher like myself, that's our bread and butter. But we are actually pretty excited and working with some companies, but also some research groups that are looking at much more low cost ways to do soil carbon monitoring. And that ranges from cool spectroscopy approaches to really cheap sensors that you would put on the soil surface and might even be biodegradable. So we're not putting garbage in our fields, but you know, these kinds of systems where we are monitoring not with a single point measurement, but with at least multiple times over multiple seasons and multiple years. That's what I think is going to be important to kind of get our heads around this and get to a place where we feel comfortable to have a carbon market.
I talked to a farmer from Velicus Farms. They're dryland grain farmers, and they had tried to. They have pretty complex crop rotations, a lot of perennial strips in their grain
Yeah.
production, and many different crops. Sort of their carbon goes up and down in their rotations, and they tried to apply for some carbon markets because of all the farmers. I was just like, wow, these guys really are doing a lot right. And they were told their farm is too complex to measure.
Uh,
So I
ah,
I think it's funny sometimes because I feel like you could get really good this there's kind of a debate in the organic and versus the regenerative thinking that, organic is systems based and regenerative is outcomes based.
mm,
And we're going to measure it and prove it, And I just have concerns that, you could take in a bunch of hay and you could get really amazing, carbon increases on your land, but I'm like, let's look at the system as a whole, So the skeptic in me just always worries that taking soil measurements, even if we could get them really accurate, we're not actually accomplishing our goal of sequestering carbon overall in the system.
yeah.
Any
This
thoughts
is a
about
big issue
how?
we've faced. We've published some papers on this. We talk a lot, this sounds really nerdy, but we talk about systems boundaries, right? So let's take compost as an example.
Mm,
If you have a soil that's, let's say, starts with 3% carbon and you truck in a bunch of compost from some other place and you start adding it year on year on year, yeah, your carbon is very likely going to go up. You're adding carbon. Like you got to be screwing up to be not seeing your carbon go up if you're adding carbon. But first of all, is that carbon, is it causing a net drawdown from the atmosphere? Are we benefiting kind of the overall climate? Not necessarily, because you're just kind of moving it from whatever that other farm was where the compost was made. It probably would have biodegraded over there. Now it's just biodegrading on your field, maybe adding a little carbon in the process. But if you just draw the system boundaries at your fence line, you're not really accounting for the broader system. Now, if your goal is simply to increase the organic matter in your field so that your crops grow better, that your soil health is higher, great. That's your goal. But that's not from a carbon marketing perspective. Our goal is more global, that we're trying to actually help the climate by removing carbon dioxide from the atmosphere. We're trying to kind of restore the carbon cycle balance of the planet. And that's kind of just moving deck chairs around in the Titanic, right? It's not actually like actually helping the overall system.
Do you feel like some of these you said within 5 years you're going to feel better about them? Are there some systems that you're excited about that are maybe taking a bigger, you know,
Yeah,
at the
I
left?
say that largely because A, I think it is a solvable problem, and B, I just see a lot of people working on it. Um, and there was actually federal investment, but maybe that's going to slow down. So maybe I'll need to kind of extend, 8 years that we'll see actually some progress. But um, it is hard to move policy But I truly believe that growers are pragmatic. They're soil scientists at heart, whether or not they have a degree. And every grower that I've talked to, whether they're conventional or organic, is interested in retaining their soil, stopping erosion, and improving the health of their soil because they know how important that it is for the health of their production systems. So I think that's why I'm optimistic that we will move forward in terms of making those measurements. Well, probably they won't get made down to a meter deep, which is what I would love to see. We won't get it all, but I think that we will make progress in the next 5 years.
Your studies in switchgrass, is that something that's talking, like going much deeper? Is that something you feel like we can incorporate in or
Yeah,
should be incorporating in our farm production?
yeah. So that's one reason why I do think that deep soil is important because there are um, mostly perennials, but even some annuals. We're working on sorghum these days, and it has really deep roots. If we distribute root carbon throughout a greater volume, we just kind of have more chances to accumulate that carbon. And also the microbes that down deep, they're just they're less of them. They're a little sluggish. They're not degrading it and causing the loss as fast as it's sort of a simplistic understanding still, but um, we do see accumulation when we get roots that are further through the profile. But that's actually not the only reason. There's some great work that came out of Kate Skou's lab at UC Davis, where they looked at these long-term trials of no-till and different kinds of amendments. And they said just what you said a few minutes ago, that what was happening at the surface is not necessarily reflecting what happened at depth in the soil. So you might be actually accumulating carbon in that upper 10 to 15 centimeters and losing it from deep soil. And that is obviously something you're not going to know unless you start making those measurements with depth.
One of the questions after your presentation that was asked, you used the word carbon flux. And
Aha.
I'm wondering if you could describe why flux, not flow, or what does that
Oh,
mean to you?
yeah.
And maybe to kind of just describe what you're talking about there, because I think organic farmers kind of have this intuitively that they are trying to keep nutrient cycling. That's kind of their job, is to keep things going. But
Yeah.
I'm just curious if you could kind of dive into that term a little bit more and what your
Oh,
thoughts.
sure. It's just a nerdy, sciencey word. I think it's almost exactly the same thing as flow.
Okay.
Um, but what is, important and has been kind of a through line in my career is we we tend to talk about pools, and those are static. If you think about the bathtub, the size of the bathtub is sort of a static thing. But if you've got the plug open and the tap on in the bathtub, it might stay full, but there is water moving through that system, right? There's water coming in and there's water going down the drain. Now, instead of talking about water, what if that was carbon and the bathtub is your field? That carbon is coming in and it's leaving both through loss of CO2 and methane because there's decomposition. There's a certain amount of dissolved carbon that actually just kind of drains down into aquifers, might even have a little bit of erosion that takes carbon off site. So the point is that you've got flow happening. And every time the plants grow and they put roots in the ground, those are flows coming out of the roots. As the roots decay into microorganisms, things are coming back into the atmosphere eventually. That's a very moving kind of vision of what I talked about earlier, that flywheel of carbon, entering and then leaving the system. A little tiny bit of that carbon might kind of get stuck and stay in the pool, in the bathtub, as it were. And we can talk about the ways it gets stuck, but really it's that flow that's happening, and that is what it's super healthy in terms of providing nitrogen, providing phosphorus for both the plant and the microbes they depend on. And so that's in a way kind of a new thinking for me, is to not want to just increase the size of the bathtub over time, increase the pool size, but just make sure that the flow is happening all year round, which is coming back to cover crops, why I just love them, and we think that they really seem to work. The data suggests they work in terms of increasing soil carbon below ground.
Have you ever looked at that debate? I know some of those minimum till annual organic farmers looked at keeping the cover crops on the surface, and they had trouble keeping that flux, that flow going because they weren't incorporating, they weren't tilling that cover crop in. So I don't know,
That
have
is
you
it.
looked at yeah, any of
Yeah,
the
super interesting. I have
trade-offs?
not. I want to be honest that haven't looked at that nuance. Um, our analysis of cover cropping was tied to a report that I helped lead called Roads to Removal. We were looking at how to remove CO2 from the atmosphere, and we were just trying to make decisions on what to encourage across the entire nation, which of course is hard, right? Because there's really different climates and soils and farming practices. And that's where we came down to it just looked like every time we looked at cover cropping, kind of generically, it was beneficial. Um, but I think that you're right that there are so many nuances of how you do the cover cropping that probably need additional study that I don't know enough about, to be honest. When I talk to farmers in Nebraska, the way that they are getting rid of transitioning, let's say, from their cover crop into their food, their cash crop is very different from the farmers here in California than farmers that I've talked to in North Carolina. So it depends on your climate, on how wet your soils are, and then yeah, a certain amount of telling that material in does seem to need to happen. Whether it happens every year or every few years, again, there's
Yeah.
different practices, different
I
places.
remember even like the different crops because they were like, well, then the rodents loved this stuff on the surface. And so for our melons, we had all these mice bites and it's just like
Oh,
very
yeah.
complicated, you know? And Phil Foster, he said it worked when he then added plastic on top of the rows because that traps the
Oh my goodness.
moisture and helped it
Absolutely.
degrade. So there's all these
Yes.
trade-offs that we have to figure out.
When Phil first told me about that, he came to talk to our group and they were using this term. I think they called it plastic mulch. And I was like, okay, sorry, what is plastic mulch? And you guys are organic. Why would you use plastic? That feels like it breaks some fundamental rule. But no, it really works because it helps warm everything up and everything degrades better. And whew, that was a big eye opener for me.
I do in the second half kind of want to nerd out and like where the long-term storage might happen. But just kind of keeping on the theme of policy, I'm curious if you have thoughts. I mean, some of the climate smart money, I was just like, this is so climate dumb when I read some of where the money went. One of them was like growing a cover crop to produce a liquid fertilizer. It was like they harvested it, and then I was like, why aren't we just like using that fertility in place, you know?
Yeah.
And
Yeah.
it seemed like the full cost accounting wasn't being done. I'm curious if you have thoughts about like certain practices that we should be, funding. There's trade-offs with everything. Like I don't know if you've been following Sigma in California, like growing cover crops needs water.
Yeah.
These things are so complicated and um, I guess do you have faith that maybe we've got some systems that we're just like, yes, this is a climate smart practice. We should be promoting this
Yeah.
across the board.
So let me just say, I am a big, big believer in place-based both science and policy. And I think that it's very difficult for the USDA, for the Farm Bill, to prescribe single policies that are going to be good across the nation. I laud them for trying. I think that in general, cover cropping is a good thing to encourage. I think the Conservation Reserve Program, the CRP program, where you put land aside, is general, like I support those ideas. I think that in general, encouraging hedgerows, encouraging some perennials on a landscape, even if you're growing annuals, like just getting some trees and some hedges and some deep roots back in that landscape, getting those prairie strips back in the landscape. There's probably a list of maybe half a dozen things that I think are just great across the country. But then when you get into the weeds, sorry to talk about weeds, of course, but to get into the details, um, we really need place-based data and solutions. And, what's right for somebody in the San Joaquin Valley might be something that's different than in the northern part of the Central Valley than in the Central Coast of California. And we are just in a very different space, both in terms of what we grow, but also our climate, than folks in Colorado, than the folks who are in Indiana. Um, and you brought up Sigma. A big project that we're leading right now is how do we increase soil carbon soils, take it out of the atmosphere in a water limited reality? And Sigma is taking, um, you know, uh, potentially millions of acres out of production in California because there's not water. If all of those acres are just left bare, that is terrible for our climate. It's terrible for our air quality because there's a lot of dust, for erosion, for many, many reasons. So I think that some of the language around how having just a cover crop on the landscape takes water away from the main crop, or even just takes water. We really need to look at the data on that because the data don't support the idea that cover crops steal from your cash crop. And especially in our California and Mediterranean climate, where we do get our rainfall in the wintertime, often you can have either an annual or a perennial cover crop in place that is supported by just natural rainfall and doesn't need irrigating. That's just putting roots in the ground that are going to hold that soil. They're going to hold the nitrogen, keep it from leaching off site. And so I do think that that carbon and water management can be integrated. They don't have to be opposing forces. And in Colorado, the story might be different. You don't have quite a Mediterranean climate, and there's changes in when is coming that maybe I haven't thought deeply enough about, but I can tell you what I know for California. Again, place-based answers. That's where I live, and that's kind of what I know most about at this point.
Oh, that makes a ton of sense. Especially with the confusion around, is cover cropping good or bad, or just leave it on the surface, incorporate it, all of that, like you said, is so place-based. I'm thinking of Velikas Farms again, where the norm is chem fallow for wheat because you pretty much need to take a full year off of wheat production, which is the crop that's subsidized. That's what everybody wants to grow. And in order to get enough water, because it's all dryland farm,
Mm.
they only really use crop insurance if you're following these practices, which are like a full year of absolutely bare soils. And
Mm.
this is thought to conserve water. And so
Mm.
that's what we're subsidizing, and that's what our crop insurance is
Mhm.
favoring. And that's why this, organic farm they're not going to herbicide and keep bare soils in it. So things didn't support what they were trying to do there, both our crop insurance and subsidies. And it just makes you realize how important scientists that know about local agriculture, their role in actually influencing policy. And that's so counterintuitive to what we're taught. Even at EcoFarm, I saw a scientist on a panel was like, well, I'm a scientist, so I shouldn't have an opinion here. And it was just like, no, you absolutely need to speak up because you probably have the most informed opinion that we should all be listening to. So I'm
Yeah,
curious if you have thoughts about um,
that
how
part.
how to
Yeah.
encourage scientists to speak up when they see a policy is going the wrong direction. How do we kind of create more activist scientists? Because I think we really
Yeah.
need them right now.
Well, you're absolutely right. That's the traditional academic disciplines. We're very taught to sort of stay in our lane and be just very evidence-based. Um, I think everyone is realizing that just publishing a paper in a peer-reviewed journal that, somebody has to pay to even access, that is not a way to influence growers or policy. It is just staying in our little bubble, right?
Yeah.
Staying in the ivory tower. And so that's why I love to see that the number of extension specialists seems to be, I don't know if it's growing, but I'm engaging more and more with those folks. And I just feel like there's such a critical spot to sit in between that research university life and knowledge base and actually direct engagement with farmers. I've seen that. I just met a guy at UC Santa Cruz who's playing that role. I know UC Merced is hiring someone. UC Davis has tons of people. But even, we have a family farm out in Nebraska. And when I was out there last, I was talking to the farm manager, and he said, I just do whatever my extension agent tells me to do. He gives me the recipe and I do it. I was like, wow, you're putting a lot of trust in that person, but great. They have a lot of influence and hopefully they're good.
Right. The importance of
Now,
making sure they're good.
yeah, right. Yeah, hopefully they know what they're doing. But um, translating that to policy, I will tell you, I don't have an answer for you yet. That seems stickier. So that path between research and growers, I think that the extension folks are the answer. But getting the evidence-based information into the hands of USDA and those Congress representatives that you said you met in DC, that is proving hard. I have several colleagues who've done we call them details, like just like little temporary assignments in Washington and engaged with USDA. And the officials there are desperate for information. But like all of us, they're super busy. They're, got a lot on their plate. They can't read literature. And how do they know which academic to trust and which, because we all have a little bit of bias, right? That's just how we get made. So I wish I had a better answer for you, but I feel like that is a piece that we need to work on is developing a better flow from the academic and grower informed world into policymaking.
And I'm afraid what we have now is they have the ear of the scientists from, the big agricultural companies or the chemical companies, that those guys do get a seat at the table in
Oh yeah.
Washington. And so
Yeah.
that's what we're trying, we're the
Yep.
huge microphone that they have, we're trying to at least get a small voice in there. And it can
Yeah.
be really challenging. There was a Nature paper that came out and it was talking about how organic farming is bad for the climate because we have lower yields per acre
Aha.
and therefore we need more land, and all
Yeah.
agriculture is inherently worse than native ecosystems, so therefore organic is bad for the climate. And it was just like, okay, I think we might be cherry picking again one piece of data. Do we need to look at the bigger picture here? Is there something
Right.
that comes to mind to you when you hear about that study, the conclusion that was made?
Yeah, I think again that's a problem of a lack of systems thinking. So just like in a lot of areas to do with energy use that we don't measure all of what we call externalities, the sort of the things that are difficult to measure usually. That happens in agriculture when, we add inorganic fertilizer. It takes an enormous amount of fossil fuel to make that inorganic fertilizer. So there's that cost, but it's off farm. There's the negative effects of that inorganic fertilizer, both in situ and the loss of nitrous oxide, which is a very potent greenhouse gas, but that seepage of usually nitrate into waterways and the algal blooms. And, again, all those are off farm and difficult to measure because they're anytime, something moves into the hydrologic cycle and is, affecting a river or the Gulf of Mexico, like that's how are you going to really measure, who's at fault or who caused what? So those systems level analyses often don't get done. They don't get funded. They take very interdisciplinary science, but encouraging as much as we can of that kind of thinking to think about, okay, well, organic agriculture may not be producing as much, but last time I checked, we're using 30% of our corn to feed cows. That we have more than we need. We have more calories than we need being produced, at least in the United States. It's not true in every country, but we're putting a lot of that into our gas tanks And we, food security is a real issue globally, but at least in this country, we have enough. We need to stop wasting food more than we need to produce, an extra 5, 10, 20% on every acre of land. I think if we produced what we produce in a more sustainable manner, that it would be, I'm perfectly fine with lower yields. That's my perspective.
JP, you mentioned cows and confinement, feeding them corn. Do you feel comfortable enough talking about a better way to produce animals, or do you feel like with
Mm,
climate, we just shouldn't be eating animals? There's kind of that debate in
yeah,
climate science.
it is a big, a thorny one. It's not an area that I have real expertise in. Um, uh, I have friends who have very, very strong opinions about if we took cows out of the landscape, we could transition so many acres back into forest, into ecosystems that are absorbing carbon. We could even potentially get paid to do that. So there are landowners, particularly in the southeastern US, where the land values are pretty low, that are barely making money running cattle and potentially could be getting paid much more in terms of carbon credits if they took the cows off and started growing forests. So that's an interesting idea. But the problem is that we do just still have a lot of demand for meat protein. And if we started doing that in the US, does that mean we cut down more forests in Brazil or in Southeast Asia or elsewhere? Those trickle down effects are really scary. And again, I'm starting to wade into areas that I don't really have data to support, but it's a tough issue. Yeah. I'll just be straight with you though that I'm not a vegetarian. I'm not a completely anti-cow person. But I do think that there are a lot of inefficiencies in the way that we, particularly the sort of whole pathway from corn to cattle in this country, that the way that that occurs.
And then putting a lot of these really large confinements in the desert where it does require a lot of water. So we're
Yeah.
talking about draining aquifers and things.
Yeah.
I mean, climate issues are inherently global. And so, you again, it goes back to place-based. And then you talked about, well, if we implement something in the US, what does that mean for what then happens in Brazil? And
Right.
could you maybe talk about anything hopeful that you feel like is happening in terms of working together, internationally on some of these issues?
There's international agreement that even if we did our darndest to decarbonize, to stop using fossil energy as much as we can, we're just not going fast enough. And we probably even can't get all the way to zero because there's just too many industries. Farming is one of them where we produce greenhouse gases that we don't have a way to avoid.
Yeah.
So we got to actually figure out how to suck, vacuum some of that extra greenhouse gas or CO2 out of the atmosphere. And I just see that as such a big win for agriculture because that we know that that carbon is actually organic matter. Organic matter is half carbon, and so there's nitrogen, phosphorus, and water holding capacity, and diverse microorganisms, and all these other what we call co-benefits that come along with that carbon. And so all across the world, nations have agreed that yes, we need to focus on this, that agriculture is a big place to focus. The carbon that we put back in our soils gives us so much benefit locally, even if the climate benefit is very diffuse and very hard to kind of even wrap your head around. It has these immediate benefits in terms of our soil health. So I see that in Europe, I see that in developing countries in the global south. I see it I was in Africa this past summer and it resonated in all sorts of places in South Africa and elsewhere. And Kenya is very involved in this. So I just think that I'm enthusiastic that managing soils in more, pick your favorite word, healthy, regenerative, whatever you want to, no-till, cover crop, whatever term you want to use, is something that seems to be just globally appreciated. And I see marketplaces developing that are encouraging it. Not in every country, but the biggest amount of carbon dioxide removal that's actually being paid for internationally is adding mostly biochar, but adding amendments to soils. And most of that's happening in Europe, but it's something that can happen anywhere. And on the horizon, there's a lot of discussion about adding crushed rock, what they call enhanced rock weathering, which is really kind of just like lime additions, but slightly different. But that's another approach that I think in 5 years' time we'll be talking very seriously about and could be benefiting soils and production across the world.
Is this like I'm in Colorado with very young soils, so maybe that wouldn't benefit me as much as more aged soils, or what is the idea here behind it?
No, not necessarily. The idea is that you take typically basalt, so they're also calcium or magnesium silicates that naturally weather. And when they are weathering and breaking down, they naturally take molecules of CO2 from the atmosphere. There's a lot of involved chemistry they create bicarbonate that then ends up kind of washing out into the oceans, but it's a net removal of carbon from the atmosphere. And in the process, there's not enough data yet, but a lot of folks are seeing benefits to their crop production. In the same way that managing pH through liming often is many soils benefit from a little lime addition. Now, you're absolutely right that your particular land in Colorado might, there might be more or less benefit than somebody in a more highly weathered or less so. Um, that's always going to be true. But again, it's a technique that's right now seen as on the whole beneficial with not too many downsides. That's kind of what we go for, right? It's something that's net positive.
You got asked a question about biochar at the conference,
Yeah,
and you
yeah,
said it seemed to be more effective in tropical soils. And I was curious if you could elaborate on that. Biochar is kind of a really sexy thing right now. So, does it make sense to
yeah.
do it in a place with
Um,
pretty cold soils?
again, I don't see a lot of downsides for biochar unless you got a batch that was made that just for whatever reason had a lot of strange hydrocarbons or something in it, which I haven't seen literature on that. I really just think it's either a net neutral or a net positive in almost all soils to be adding biochar. Um, it's uh, it's again back to those systems boundaries that if you take biochar that was made offsite and you um, maybe you made it from trees or you made it from corn stove or whatever you made it from, and you add it to your site, um, do we at the system level call that a net carbon increase because that biochar is going to probably stick around for a long time in your site? Well, you kind of just moved things around in the landscape. Some folks have seen, though, that when you add biochar to a soil, that the productivity of that land actually increases. We're not entirely sure why that is, but some folks think it has to do with those biochar, when you look at it in a microscope, kind of looks like pumice. And what I mean by that, it's got a lot of surfaces. It's just got a lot of little kind of crevices and holes. And though each of those, if you can imagine, it has a little potential to react with an ion like nitrate or ammonium or phosphate. And a lot of those are things that we want to hang on to. So if what that biochar does is it takes a pretty inert material, but creates just a lot of surface area to grab good things that are, that we want to kind of be slow release so that plants can, get at that ammonium, but not all in one day, kind of over a long period of time. Then I think of it as in a way kind of it's not a fertilizer in itself, but if it allows the system to kind of have time to access those nutrients over us, and it stretches out that process, I wonder if that's the benefit. And I have little data to support that, not enough, but the carbon itself that's in the biochar is really pretty inert. It is in such a cooked pyrolyzed form that it's not really interacting. We actually see very little decomposition. But it's that surface reactivity that seems to have um, the beneficial effect that people have measured in some systems.
Okay, when you're speaking, tell me if this makes any sense. It seems
Yeah.
to me that it might be more beneficial. Say if you're applying fertilizers and you know how they say at most, only a third are taken up and the rest kind of wash
Yes.
away. So it
Right.
might be great at holding on to what you've applied. I'm curious if you're an organic farmer and you're thinking about that cycling and you've already, you're growing your cover crop in place and it's a diverse cover crop, so the nutrients are kind of breaking down over time. Is there any concern that biochar might lock up something that you need that might be readily available? Does it have different applications for a farm that's applying fertilizers that
Mm,
are readily available versus, a kind of a traditional organic system where you've got
mm.
the breakdown of organic matter over time is what's feeding your crop?
I think that's an interesting hypothesis, and I can't tell you that I've seen anybody really study it.
I got to go back to grad
Um,
school.
you do. I think that, a lot of the organic farmers I engage with are functionally in grad school. It's just they're
It's true.
too bad they're not getting to get an official degree because they deserve it.
They're doing so much
Um,
research on their farms.
but
Absolutely.
there's some great studies, not enough, but a couple on um, what we call co-composted biochar, where folks have actually mixed biochar in with compost, or it's been part of a municipal industrial composting system. And what I think that does is it charges up all of those exchange sites in the char. It gets all those great nutrients absorbed. And then when you add it, you got some compost that's actually just providing nutrients instantaneously through microbial action. And then you got that more slow release kind of fertilizer effect that's coming from the char. That's a guess. I
Okay.
would really love to see somebody test that in a really careful way. Um, but I've not seen real downsides with char additions, with and without compost. I don't know a ton of farmers that do it. Um, it's goes back to policy. It's not something that's been encouraged, but I think could be.
Do you think that the applications in tropical soils are because of so much leaching from all the rain that it's just the capacity to hold on to it? It might be why it's working there so well.
It certainly could. Tropical soils, on the whole, have a very different net charge. And this is, again, kind of in the weeds on soil chemistry. But the types of ions that are held, they're bound well in tropical soils are very, very different than in the temperate zone. And it has to do just simply the amount of weathering. They are at the far end of the weathering spectrum. The soils are so old, they've lost a lot of we call them short range order, but they're the types of minerals that are really grabby, that are good at holding on to ions. And so you're kind of left with um, mineral phases that are mostly clays and iron oxides that are not as good at hanging on to some of those nutrients that are so important to our plant growth. So in some ways, adding that char just again kind of rebuilds that ability um, to hang on to those important ions.
Hmm. I'm very aware of our time. I'm wondering, I know that so much of what we're doing, we farmers want to be involved. They want to be stewards. A lot of times we're told something's great and then we find out later it's not. Um, you know, Maybe the role of the farmer, your thoughts on, do we need more farmers on the land? And, can we be involved in the processes, involved in the politics? What is the kind of in the future you see if we're really going to create an agriculture that helps with climate? Can you see it out? Can you envision? I mean, does it look like maybe just machines on the land and it's like everybody's, kind of removed and they're in cities and it's all automated? Like, do you
Oh,
have
no. No,
in the
no.
realm of anything possible, do you kind of have a vision of where we need to be going? Just,
Here's, I think, what I would ask of the farming and grower community is, I made that little comment earlier about you're all science, as much soil scientists as I am. What's different is the collection of data. And I would encourage growers to collect as much data year on year as they can. as they can afford and as they can afford the time to keep track of it. Or collaborate with a soil scientist or with your extension agent to keep data on how much you're producing, what your soil chemistry looks like, what you've added, how much you've added year on year. Try to keep that information per field. And I know that's hard. That's what our bread and butter is. But what we find when we go to engage with a grower is that history is kind of all in their head.
Yeah.
And it's not written down. It's not, in a digital fashion. And that personal history is super, super important. I always interview a grower if we're going to go work in a new site. But being able to look at how things are actually changing year on year on year, when you add compost, when you do this, when you add fertilizer, when whatever it is you do, is the only way we're going to be able to collect enough information to truly kind of get a sense of what are the right practices. You mentioned that sometimes you're told to do something and then you learn later, oh no, that's the wrong thing to do. A lot of this, the reason for those kind of ups and downs is because we just don't have enough information across enough different climate and soil contexts. And if we I have been nagging the state of California with some of their Healthy Soils program. They've been collecting data from farmers for a decade now, but they haven't made it public. They haven't shared it back out. And that is what is really critical, is that all of that information gets collected, but then it becomes publicly available so that we can not point to the one farmer who didn't do a good job, but to understand across all of many hundreds of farms what seems to be working. Because I do think that every farmer is actually every year carrying out an experiment. And the piece that is, I'm not even going to say it's missing, because most farmers actually absolutely know what their production level is. But there are a couple of other critical pieces of information that I would love to encourage that folks collect.
What comes to mind when you're talking is too complex to measure. It's just like our systems at the farms that I visit, it's like, they've got pigs and chickens and, vegetables and greenhouses. And so it seems overwhelming. So collecting data, but like what data, we do need help and guidance in that process.
In what that is.
And do you want these complex farms as anything that you could use, or is it too complex to know what's going on?
Well, let me just say this. So Ida Guzman, who spoke in our session at EcoFarm, she's done some wonderful work in polycultures here in California. These are farms where they sometimes have 100 different crops growing on a single acre, which is mind-boggling. But she sees significant increases in soil carbon and really significant increases in the diversity of the mycorrhizae, but also just the total microbiome, the organisms. And so I call that healthy soil. Those are my metrics. And so that diversity that you're talking about, whether it's in the number of different crops or having the pigs and the compost and the all of the things, I think those always have a net positive benefit.
Thank you, JP. We'll do part 2 when we find the time. I really appreciate it.
All right, cool. It was great to talk to you, Linley. Thank you.
Have a good flight.
All right, see ya.
Thank you for listening to the Real Organic Podcast. Our movement is growing because you're subscribing and sharing these podcasts with your friends. So keep it up and leave us a rating and a review as well so that others can find us. You can find a video version of this interview on our newly designed website, realorganicproject.org, or on our YouTube channel. And you can join us every Thursday for a new episode featuring voices from the organic movement. See you next time.